We're going to jump right back in with Victor, who will be presenting on groundwater reduced monitoring plan.
Okay. I'll be talking today. I hope everybody's doing okay. My name is Victor Scheer. I'm with the ADEQ Source Water Protection Plan section. I work with David Bouchard. We also work on special projects. One of the special projects we're working on in the last few years is the PFOS, which is the big buzzword now. Everybody's probably heard of that. So I'm going to kind of give you an overview of what PFOS is, and then we're going to get into UCMR5, what that is, the unregulated contaminant monitoring rule. I'll talk a little bit about that, and then we'll get into the actual examples of the representative groundwater monitoring plan. Next slide. Just kind of a background. I've been with the ADEQ for 30 years. Like I said, I'm with the Source Water Protection Program Plan. I've been in the regulatory part at ADEQ, the oversight, for about 15 years. Before that, I was with the state of Utah. Currently, David Bouchard and I, who do the Source Water Protection Program, we've completed 80 source water protection plans throughout Arizona, and we provide regulatory oversight and work with over 1,600 public water systems throughout Arizona. Next slide. So, UCMR5 PFOS sampling. So let's start by just kind of going over what are PFOS. It's a big word now. First of all, if you get nothing else out of this presentation, one thing that you need to know is PFOS is everywhere. And we have been around PFOS for the last 30 to 40 years, including Teflon skillets when we cooked on that cookware. But PFOS stands for perfluoroalkyl and polyfluoroalkyl substances. It contains several categories and classes of durable chemicals and materials with properties that include oil, water, temperature, chemical and fire resistance, as well as electric insulating properties. These characteristics are critical for use in important applications across many industries. And of PFOS contains thousands of different compounds. We have done 2 studies on PFAS in the last several years at ADEQ. The first one focused on PFOA, which perfluorooctanic acid, and PFOS, perfluorooctane sulfonate. And those are just 2 of the compounds that we looked at in phase 1 of our investigation, where we did PW public water system screenings throughout the state. And these 2, like I say, are part of the overall PFOS compounds. And like I say, there are many, many PFOS compounds, several thousand. We'll get into what's required in the UCMR5 PFOS sampling program subsequently. But anyway, they've been used to make carpets, clothing, they're fabrics for furniture, paper packaging, even the food wrappers from McDonald's that hold your hot coffee and your Big Mac. They have PFOS in them. These chemicals are these chemicals are used because they're resistant to water, grease, or stains. For example, if you have carpet and you have carpet protectant, that contains PFOS. The main source of it, though, is firefighting foams, which we'll talk about shortly. 3M is the company that first produced this chemical, and between 2000 and 2002, they voluntarily phased out the production in the U.S. 8 other major companies voluntarily agreed to phase out these as well. So they have been phased out. Next slide, please. And these are just, these next couple of slides just showing you the type of products that these chemicals are used in. Grease-resistant paper, fast food containers, wrappers, pizza boxes, microwave popcorn bags, candy wrappers, water-resistant clothing such as Gore-Tex, some adhesives, some cleaning products, Personal care products such as shampoo, dental floss, and cosmetics. A lot of the cosmetics, they're waterproof. They have PFOS in them. Paints, varnishes, and sealants. Film. So you can just see from the slide a wide variety of products that these compounds are found in. Next slide. The number one source of PFOS is firefighting foam. For years they used this foam because it works so well to put out aircraft fires, burning cars, or whatever. The main source of these were for years at fire training facilities. They used these compounds when they were practicing to put out fires. And like I said, the AFFF, which is the aqueous film foaming foam, is the number one source of PFOS. So when we were looking to sample these wells, originally we were primarily in phase 1 of the sampling, which we're now in phase 2. We were looking around these fire training facilities. One question that we often get that I'll just make a note here, the red retardant that you see drop from the airplanes when there's wildfires, that does not contain PFOS. That's a different chemical. Next slide. So the main thing is, the problem with these things is these chemicals don't break down, and they persist in your body and the environment for decades. They're very resistant to remediation. They don't break down. And as a result of this, more than 95% of the population has PFOS in their bodies. And this is studies that have done by EPA and the Centers for Disease Control and Prevention. Next slide. So this is just a slide here that shows the states in the U.S. with over 2%, over 10% public water system detections, and then the yellow is the 5 to 9% of PWSs that have these chemicals that have been detected. So as you can see, the wide range problem, and it extends throughout most of the U.S. Next slide. And this is kind of a slide here for hydrologists, but it's basically showing us the aquifer impacts across the U.S. So the main thing I wanted to show here is most of the little areas in blue, all these aquifers have had detects throughout the U.S. If you can look along the eastern portion of the U.S. on the map there, that's where you would expect to see more of the concentrations of these chemicals due to the industrialized areas throughout the Northeast. Next slide. So PFAS has currently no MCL. PFOA and PFOS, which are the two compounds, just two of the compounds in the PFOS array of compounds, have a health advisory limit established by EPA of 70 parts per trillion. That's a combined health advisory for both PFOA and PFOS. So if you sampled a well and the PFOA was at 40 and the PFOS was at 20 for a total of 60, it would be below the health advisory. We've been told that an MCL is coming, at least for these two chemicals on the compound, probably more. But we're looking at 2023 or beyond is what I'm hearing of when that might happen. Another thing to keep in mind is how small are parts per trillion. These tests, to test this water for PFOS, it's very expensive, and it's because the detection limit has to go down to parts per trillion. Most of the water parameters that the PWS is sampled for are in parts per billion or parts per million. So this is much, much smaller. And I'm hearing, I don't have just kind of what I'm heard through these advisory committees that I've kind of followed in the webinars is the 70 parts per trillion current health advisory is too high. The MCL or health advisories that are established in the future are more than likely going to be much lower. Next slide, please. So let's just talk about how the problems with these compounds. You may have heard, you know, on TV or something when you're watching about these chemicals that they're called the forever chemicals. That's true because they don't break down in the body very easily. They're not metabolized, and they're resistant in the environment. So they can stay there for decades. These chemicals in the human body have been linked to a lot of health problems, including high cholesterol, suppressed immune systems, infertility, some cancers, and amazingly some reduced efficacy of some vaccines. So they can even prevent vaccines from working efficiently. And you can see through the little graph or the little arrow with the body on it on the right of the slide that it basically doesn't really get metabolized very well and stays within the body for a long time. Next slide. So this is, interestingly, EPA did a study back in 2016, I believe, and they took random blood level samples from populations throughout the United States. Everything from 3M workers, which you see on the top part of the bar chart on the right, to just generalized U.S. population. Every person that tested had this in their blood. You can see the bar graph at the top, which is the highest concentrations which you would expect from workers at these facilities that manufactured these chemicals. Generalized population, much lower. But the one thing I wanted you to get out of the slide is that everyone tested had these chemicals in their body. It's a real problem. I think they're going to probably be remediating this stuff for decades. And of course, we've talked about some of the health problems that they can cause. Next slide, please. This was our first report, was on our ADQ PFOS screening. We did this in 2017 and 18. The report was published on 2018. It's on our website. You can easily Google ADQ PFOS report, and you'll go to this report. We finished that report, and we were funded by the EPA to do that. We're currently in the phase 2 of the report, which I'll get onto in the next few slides. Next slide, please. If you look at that report, it shows that 89 wells, which were 81.7%, were non-detect. 14 wells had detections, about 12.8% of the wells, but were below the EPA health advisory, and only 6 wells at around 6% were above the EPA health advisory. So it wasn't a widespread problem that we're finding in phase 1, but you have to remember in that portion, we're primarily only looking at one source. Since we've opened up for our phase 2 investigation, which started in 2019, we're looking at a lot more sources and a lot more compounds than we did when we looked at just PFOS and PFOA in the original report. Next slide, please. So the phase 2, we are currently conducting that now. We're looking at additional compounds. We're looking at 18 total compounds. We looked at 2 compounds in the first screening. This one we're looking at 18. It's ongoing. We're currently winding up that sampling event. And we're estimating that we should be finished sampling by early spring, and hopefully shortly thereafter, we'll be submitting a report which will be up on our website. We're additionally also in the process of doing an interactive map where you'll be able to go onto and click on the public water system and see the well concentrations of these compounds. We've sampled approximately 210 additional wells from the 150 that we sampled in the first phase. And like I stated, additional sources have been sampled during this. And the report will be coming this spring. Next slide, please. So So let's just talk about these detection limits. How small is parts per trillion? And these are kind of a couple of slides that are kind of fun to look at. And they give you an indication of just how small these detection limits are for this compound. And they're in parts per trillion, which is 1,000 times smaller than the part per billion. And 1 part per trillion is equivalent to several drops of water in an Olympic-sized swimming pool. So it's really hard to kind of put your head around something like that is that small. Or another example is traveling 6 inches on a 93 million mile journey toward the sun. Next slide. Some more examples. 1 second out of 32,000 years, 1 flea on 360 million elephants, and the area of 1 postage stamp in the city of Dallas. So extremely small detection limits, hence, unfortunately, the higher cost, the laboratory charges for these samples to be analyzed. Next slide. So I'm going to get into, before I get into the UCMR5 requirements, I'm going to get into some of the requirements. You folks, if you're working with doing some of the UCMR sampling, PFOS is kind of a special breed. You have to take additional training. You have to do additional precautions so that you don't get contamination. One of the things that UCMR5, when you do sample for PFOS, they're going to require that you pour a filled blank, and they want to see, it's just one of the QA/QC measures that we do, but they're going to be requiring as well in UCMR5 to make sure that the area around the well from the air, you're not getting any PFOS blowing in and around the air. So those drive up costs as well. But when you're sampling for these, you have to wear cotton clothing that has been washed several times, no fabric softener. You can't use any kind of Gore-Tex, rain repellent rain gear, or footwear. So if you have boots or so forth that have been sprayed with Scotchgard, that's a no-no. Next slide. You have to use an aluminum or masonite clipboard. We recommend a field sampling checklist, which I can share with you that we use to check off, these parameters before we sample to make sure everything's done correctly. The sampling's requiring the use of ballpoint pens or pencils, no Sharpies or markers as they have PFOS in them, and use the Ziploc bags for storage and shipping. And another aspect of the sampling is you can only use wet ice. No chemical ice packs. Gel packs can be used for sample preservation. So just something to note. Next slide. Limit use of shampoo. A lot of shampoos have these products in them, these compounds. We recommend no cosmetics, scented products, moisturizers, insect repellents on the day that you'll be sampling. If sunscreen is necessary, we recommend a couple of brands that have been known not to contain these PFOS compounds. One is Alpha Organics Natural Sunscreen, and another one is Just a Cucumbers. So you just want to make sure that if you do use sunscreen, it's PFOS-free sunscreen. Next slide. Okay, just to continue through our sampling process, you thoroughly wash, rinse, dry hands before initiating sampling activities. Open sample tap on the wellhead. We want the UCMR requires, our PFOS sampling, requires that you sample prior to treatment. So we sample at the wellhead. I think on UCMR5, the sampling is done at the EPDS regardless. But we sample currently we sample before any possibility of pre-treatment. We let the well run for 15 minutes to flush. And we use a pair of nitrile gloves for every sample collected. We fill out our checklist for sampling. We collect samples into the laboratory provided sample bottles, which is ATPE or polypropylene. Gently agitate the cap gently agitate the bottle after the cap is secured. And you want to leave a small amount of headspace in the sample bottle. The reason for that is the preservative is a crystal preservative called trisma. And if you overfill that, there's a chance that trisma can get poured out of that bottle. Do not rinse or touch the inside of bottle. Next screen, please. Place them in a Ziploc bag. Transfer samples to the ice chest with regular ice, not dry ice or blue ice. Transport the sample container to the laboratory with the completed chain of custody form within 48 hours of collection. Another thing that if you are sampling for PFOS, you want to use a lab that is EPA certified to run 537.1, which is the EPA method for PFOS. And they require that these samples, well, they do not like the samples to come into them on Fridays because they have to be shipped out, and it gets too close with that 48-hour holding time. Next slide. Okay, so now after we kind of talked about PFOS a little bit, and we have talked about sampling and some characteristics of those compounds, let's look at unregulated contaminant monitoring rule. So the EPA uses the UCMR, the Unregulated Contaminant Monitoring Rule, to collect data for contaminants that are suspected to be present in drinking water and do not have health-based standards set under the Safe Drinking Water Act. That would include PFOS and whatever else EPA is studying. The list usually changes. The sampling occurs, the program reoccurs every 5 years. So the contaminants, the unregulated contaminants are different for the most part, or have been expanded based on what EPA studies that could be a threat to drinking water. Next slide. So UCMR5 is getting here fast. Sampling is scheduled to begin January 2023, but you need to start preparing now. Familiarize yourself with the final rule under UCMR5. More public water systems will be required to sample than before. There are approximately 4,300 systems that will be sampling that serve over 10,000 people. There are roughly 6,000 systems that will be sampling serving between 3,300 and 10,000 people. That's new for this go-around. 800 selected small systems will also be required to sample. Those systems are selected by EPA. So the systems are notified, the small systems are notified, and they will be required to sample. But that's just the ones that are notified to participate. 29 PFOS compounds, which is the most ever, will be sampled this time around for UCMR5. 1 metal lithium, and as you can see, the UCMR5 is heavily focused on the PFOS sampling. One thing to note is that 5 will require sampling at fewer points than previous rounds of UCMR. There were samplings that occurred at each distribution system location and source water and surface water previously under the UCMR rules, and it is only the entry points to each distribution system that will be required to be sampled under UCMR5. Next slide. This is just basically a timeline. I'm not going to go over through everything in this timeline. You can look at this when you get a copy of this presentation, but this is just a timeline that things have gone through for UCMR5. When they were added, things were passed or so forth, and decided upon what was, going to be required. Part of the uncontaminated monitoring rule is that larger systems can present a plan that will have to be approved by either the EPA or state. In Arizona, we ask that the plans be submitted to ADEQ for review. But they're called groundwater representative monitoring plans, which I'll get to in some subsequent slides. But for now, you just need to know that they're due to us by July 1st, 2022, so this July. The sample schedules also must be submitted to EPA 6 months prior to the sample collection, and sample collection beyond 2023 and 2024-25 the EPA will give you additional time to develop and propose those plans. So initially, those plans need to be by us, but just remember July 1st is the deadline. And these plans are specifically for larger systems. The smaller systems, it's really not needed because the EPA is paying for that sampling, so there would be really no savings of presenting a groundwater representative monitoring plan, which I will get into the components of that. Next slide, please. So the highlights of the UCMR sampling, they're anticipating a total of 10,300 systems. Sample collection during the 2023 through 25, following the sampling schedules. All samples, along with FRBs, reagent blanks, fill blanks, are to be collected at entry points to the distribution system. Source water systems sample 4 times, systems sample 4 times, 3 months apart during the year of sampling. Groundwater systems sample 2 times, 5 to 7 months apart during the year of sampling. Surface water and groundwater under the influence is the 4 times. Systems must follow the sample event codes. I don't know a lot about these SCE codes, but these are the codes that are required by EPA, which are submitted, I guess, for the entry into their data system. Next slide. So this kind of gets into the scope. Assessment monitoring, 30 contaminants and methods. So they're going to be doing 25 PFOS compounds. The EPA method for the 25 specific compounds will be 533. 4 PFAS compounds will be using 537.1. ADEQ in their screening is currently using 537.1. Lithium, the method will be 200.7. Small systems, basically 800 randomly selected surface water, groundwater under direct influence systems, and groundwater systems will be participating. And as I said, the question is who is paying for these? EPA is paying for the sampling for smaller systems from 25 people to 10,000 people. So the larger systems that are funding the sampling themselves obviously would possibly consider submitting a groundwater representative plan, which we'll get into the components shortly of that. Next slide, please. So we know we've learned a little bit about PFOS, what it is. We've learned a little bit about the timeline and what's going to be required in UCMR5. So let's break this down a little more and talk about what is a groundwater representative monitoring plan, which basically will be for larger systems. It's a plan that allows the public water system to sample a subset of wells that would be required to sample under UCMR5 if the wells can be shown to be representative. For instance, if there's a well field and there's 20 wells in a geographic area, if you can show that those 20 wells are drawing from the same aquifer and are representative, then you can take one of those wells to represent all of the wells. And that representative must be shown by a plan and submitted to ADEQ based on hydrogeological data, well location and construction, susceptibility to contamination, water quality parameters. All the wells would either have to be treated or untreated, the same. So if you're looking at a well field of 20 wells that have treatment, 10 wells, or 10 that have treatment, 10 that don't. That wouldn't work. All 20 would have to have either treatment or non-treatment, and then one selected well could be used to be representative of all 20. Next slide. So prior, this is important because EPA has made a decision that prior plans can be used for UCMR5. So if you had a plan under UCMR4 that had no significant changes, in other words, nothing has changed, you have not added new wells or rerouted wells and so forth, but the plan is basically the same as it was under UCMR4, and ADEQ approved it under UCMR4, it can be resubmitted for UCMR5, and EPA should approve it. Water systems, what would happen would you would submit your state approval letter to EPA, and then it will be approved if it was approved previously. Next slide. So basically, this is just kind of a real general slide stating again that the GWRSL locations, which is the groundwater representative sampling location, and that acronym is GWRSL, must represent all the wells that draw from the same aquifer. So just a kind of a general idea on that slide. Next one, please. Okay, we're going to get into some components. And I'll just kind of say from my experience, the largest system that I worked with was the city of Tucson. We got that approved in UCMR4. My colleague had worked on a couple of other plans, but so far we've only looked at about 3 plans that have been submitted to us in the past. And these are some component examples. EPA really doesn't have a lot of detail. If you go onto their UCMR5 website and you look specifically under requirements for groundwater representative monitoring plans, they don't have a whole lot. They're basically very general on the information. So that's interpreted as you supply the information, you make the best case that you can that your wells are representative, all your wells are representative of one sampling location. And if this EPA agrees with that, then they'll approve it. So it's kind of up to the water system to submit the information, and hopefully it's approved by the state or EPA. These are some of the components that we have seen, that we've worked with the public water systems that have presented these plans. These components have been contained within those plans that were approved. One of the components, site maps, we want to see the location of all wells, including the distance of each well from the proposed groundwater sampling location. Pretty simple. Geographical information, including any surface water features, drainage, roads, major potential sources of contamination. Basic information on the wells, including depth and lithology. Hydrogeological information, including aerial extent, thickness of the aquifer units, regional and local groundwater flow direction, and other relevant geological features. So more data that you can present for your case, the better. Wells considered as representative must be within 1/2 mile. Actually, it can be up to a mile. We've had several that were about a mile apart, or within a 5-year time of travel as your selected groundwater representative sampling location. We want to see a map, of course, and a scale. Next example, please. Slide. Just some more site map information, map, key and scale, which we have talked about. Location and distance from the sampling location. So we want to see your groundwater representative monitoring location well, in addition to the wells that are representative on a map, which is pretty logical. Sources of contamination that would be considered in the area. This map, or this slide here, the little square box here came from the city of Tucson. They gave me permission to use some of this information in my presentation, but they were pretty thorough. All the sources of contamination were identified, well depths, construction, and most of the hydrological information that we've talked about. Next slide. More site mount examples. This may be kind of hard to read. This is from City of Tucson as well. This is they basically divided their well representative into 10 different locations, if I recall. This is one location that that this picture here shows. So it's all the wells. They identified the representative sampling location. I think it's by the star at the top, and all the wells that they considered representative of that well. They included the ADWR well numbers, EPDS locations, and they classified them into groups. So just kind of an example of how one system presented the information. Not to say this is the only way or the best way, it's the way Tucson did it, and it got through, it got passed, approved. Next slide. One of the, what I talked about briefly, susceptibility of the proposed area. All the wells have to have an equal chance of contamination from a source of contamination. Each well within the area should have the equal possibility of contamination. So if you have wells that are near a source of contamination, whether that could be a UST, a landfill, or whatever, all wells selected must be representative and have an equal source of impact from that contamination. Justification should be included within the proposal. If none of these additional potential sources are applicable to your drinking water system, provide an analysis of the susceptibility of the wells to the most significant source of contamination in the area, including an estimate of the hydraulic travel time of travel of the source of contamination. Potential sources that you need to evaluate, UST, leaking underground storage tank, wharf sites, and other sources of contamination, landfills, industry sites, wastewater discharge, agricultural irrigation, septic tanks, animal farms, deep injection wells. So those aren't all of them, but those are some of them that could be evaluated. Next slide. Similarities of groundwater for proposed areas. Provide data that shows the groundwater at the wells within the pros are similar and representative of the wells within the area. So you're going to have one GWRSL, which is the representative sampling locations of all the wells. Well data will include, which I briefly spoke about, well depth, construction method, boring logs should be submitted, detailed lithologic descriptions, screen interval depth to groundwater. The representative, this is important, the representative well selected must have the highest volume of production. Include historical and representative water quality data. EPA just gives a very generalized some of the parameters. I've included a few more here. You can look at pH, that's a good one. Total dissolved solid, hardness, conductivity, SOCs, VOCs, metals, and so forth, and an explanation of why these parameters are relevant for each well. We'll get into a little more detail of this in subsequent slides, and provide basically what you're doing is a hydrogeological analysis of the aquifer and relevant geological features. Next slide. Summary of the proposal should be included. The groundwater plan should demonstrate that any sampling location selected as representative of the groundwater supplied for multiple wells draws from the same aquifer as the multiple wells and is associated with these wells based on the requirements. The summary then will be the basis for the decision by ADQ to grant approval of the specified groundwater sampling location. We don't want just a data dump. We want the data interpreted in a format that's easily understood by the reviewer. But we've had in the past some folks just provide us with the data dump, and that we won't approve that. Next slide. So again, this we've talked about a little bit, but the susceptibility to contamination at wells must be the same. And we've talked about these: deep well injections, septic tanks, agriculture, irrigation, wastewater discharges, landfill, industry. Those are just some of the things that you can look at. So the case to be made on this is basically the burden on the public water system. So you want to make the best case that you can, and hopefully, if you've done that well, then it will be approved. Unfortunately, EPA doesn't have a specific guideline on how these are prepared with a lot of information. I'm just kind of going over the things that we've seen from the few that we've evaluated, that we approved, and subsequently EPA approved them. Next slide. Real quick, these are parameters that we've talked a little bit. You can use pH, total dissolved solids, hardness, metals, conductivity. This is important. The one thing that you cannot use is nitrate. You cannot look at comparisons of nitrate concentrations of wells. EPA does not consider nitrate a good parameter, and if you use it, it will be rejected. So do not use nitrates. You can use some of the other ones here, but just keep in mind that nitrates are not a parameter that can be presented in your plan. Next slide. So again, we're looking at relative homogeneity of water constituents, pH, dissolved oxygen, conductivity, iron, manganese, just as some examples of things that you can use, parameters in samples from each well. I've said before, all wells need to either have the same treatment. The wells that you evaluate either have the same treatment or no treatment. Wells located in a geographic area, all wells need to be located within 0.5, and sometimes we've approved wells as far as a mile or just a bit over a mile. But if you can keep them within a 0.5 mile radius, that's better. The further you get away, the more complex it becomes, the more data that you have to submit, and it gets more difficult. So obviously, if the wells are closer, it's a little bit easier to demonstrate that they're representative. Next slide. So basically, this is just, some of the sources that this one came from Tucson Water as well. They looked at fluoride, if the wells had disinfection, treatment, absence or presence, which we've talked about. So just some of these parameters that showed up in their plan. Next slide. This is just another slide that shows another one of their areas in the map on the right. They detailed the cluster of wells over to the left, which are kind of hard to see, and then they've done a good job of drawing a little map over that showed these different zones that they were using. I think they used 10 or 11 zones, if I remember, and this map just shows which wells are in which zones. And it was a good way, to demonstrate that. Again, similarities, geography, aquifer characteristics, groundwater stressors, groundwater management. So there's a lot of things that can be used to show representative. It's not one size fits all. Some systems may have others that I haven't mentioned here. Some may have these, but you use what is best for your water system data that you can use to make these cases, as well as being drawing from the same aquifer and being representative. These are just examples on some of the ones that we've seen. Next slide, please. This is just driller logs, basic information. I'll go real quick over this. This is attached to the monitoring plan: well depth, casing depth, description of the casing, casing diameter, material that the casing is made of, and so forth. So just general well data is presented in this table. This is another Tucson water table that they submitted in their plan. Next slide. Well volumes produced. So they gave basically all the wells and the volume that each well was producing, and you just want to remember, for the representative sampling location well that you're using to show representative of other wells, it has to be the highest volume produced well. Next slide. Evaluate distances. So you'll see here that Tucson did make a case. One well was 1.6 miles away, but generally you can see the wells are pretty close, between a half a mile and a mile away. Next slide. What we don't want to see is one well and then you're trying to make a case that a well 5 miles away is representative. That won't fly, because that's just too complex and would be too hard to accurately show that the well would be representative. These are some just more examples of the table, one of the tables that was found in Tucson. They just basically listed, here they use iron, manganese, fluoride. You can use those, you can use different ones, whatever is applicable to your water system. These are the ones that they happen to have data on, so they were used. They used the percent difference at each sampling location, and they also did a statistical study based on the percentages and so forth, which can be done as well. Next slide. And this is just kind of showing you how they presented the data. This was for fluoride and the averages in the well, which did a really good job of demonstrating that graphically, and it makes it really easy to present the data. You don't have to do it this way. You can do it in a table if you're using, whatever compounds or whatever, metals or whatever that you're using, pH values, TODs, whatever you're using, you can present it. This is just one way to present the data. Next slide. It's a couple more on water quality parameters. These are fluoride, pH, iron, manganese, just to show you. Generally, they're all within an acceptable percent difference. Next slide. This is just another example of Tucson water in the one area that they were using. The representative wells are the stars, and the other groundwater wells, which are shown as black dots. So basically, they're sampling 3 wells here, representative of all those other wells. Next slide. And this is just basically showing the wells and the concentrations of VOCs, so it's kind of just showing that data set. Next slide, I think they have one where they're showing the SOCs. This is the statistical analysis they did. I just pulled this from their report as well. You do not have to do a statistical analysis. They just did it, which kind of strengthened their case on well representativeness. We've had some that have included these analysis and some that have not. It's not required. It's just another tool that you can use to show that the wells are representative. Next slide. Okay, and if there are differences, we like to see the ranges of, for instance, if it's a fluoride concentration, we want to see those wells within 15% difference of fluoride concentrations. If you have, so 15% is kind of the norm. If you have differences greater than 15%, it still can be used, but you need to justify why the actual difference is above 15%, then why they're still representatives. The burden, again, is upon the PWS to identify those differences that are greater than 15% differences in concentration and justify that. So I know that we have approved some that have differences of around 20% in the concentration, but if you get much beyond that, it would be pretty tough. Next slide. So just an important reminder, kind of wrapping this thing up. July 1st of this year, if you choose to do a groundwater representative monitoring plan, it needs to submit it to ADEQ for approval, and then we approve it and submit it to EPA. If they agree with our decisions, then they approve it. Fortunately, the ones that we have approved in the past under UCMR5 have gotten EPA approval, but you just want to remember that they need to be submitted to ADEQ, your plan, by July 1st. And as another reminder, these plans will only be prepared by the larger systems that have, lots and lots of wells, like Tucson. Next slide. So any questions? I tried to give as much detail as I can, but the one thing that I've seen is EPA does not, again, provide a lot of detail in this. It's kind of, their philosophy is the burden is upon the water system to prove representativeness when submitting a groundwater representative monitoring plan. If they agree with it, they'll approve it. If they don't, they'll deny it. I'm just giving you some examples of things that we've seen and worked with our water systems. We haven't had a lot of them. There's only 3 or 4 that have ever been submitted, but I do know that they contain the components that I've presented here, and they were approved. So that's it. Now I'll ask for any questions. The next slide you can go to, Jane, is our contacts, David Burchard and myself. Should be one more slide.
Hi, Vic. It seems like that was the end of your slideshow, but we do have a presentation.
Okay,
some
yeah.
questions for you. The first question is, what size systems are required to submit the GWRMP? Who is approving the plan? Is it the ADEQ or EPA? Are we submitting to ADEQ first or submitting to the EPA CDX? Is there any info for treatment options, or at what point will EPA require treatment?
Okay, the state of Arizona has decided that they are going to review the plans. We have an agreement with EPA. Some states don't. They let EPA, they're submitted directly to EPA. If they're within Arizona, they're going to be submitted to ADEQ. Myself or David Burchard, which is the other hydrologist that I work with, will review these. Once we approve them, we send a letter to the water system and a copy of the approval to EPA. And fortunately, the ones that we have approved, EPA has approved, but please submit those plans to us, not to EPA directly. The other question that you have is, what was the question, Jane, about the EPDS? Was it one?
Sorry, it was, are we submitting to ADEQ first or submitting to the EPA CDX? Is there any info for treatment options, or at what point will EPA require treatment?
Representative monitoring plans don't really have anything to do with requirements for treatments. All we're saying is, if you're looking at a well field that has 20 wells, and you're selecting one well that's representative of all the other 19, all 20 wells have to have either no treatment or treatment. You can't look at 10 that have treatment and 10 that do not have treatment. So it's not a question of approval of treatment. We want representativeness. We want either all the wells being evaluated, that you select one well as representative, to either they all have treatment or they do not have treatment. And what was the next question again? You fired up about 8 of them.
And the next question is, will EPA get a hold of us if we are testing?
Yeah, what happens is once you submit the plan to ADEQ, we will approve it or deny it. We will send you a letter if it's approved. Then we submit the approval letter and the actual plan that you've submitted to EPA. So at that point, EPA will either approve it and agree with ADEQ's decision, or they can deny it. So they can still deny it even though we approved it. Fortunately, that hasn't happened. Every plan that we've approved at ADEQ and submitted to EPA, they have approved. So that's why I'm kind of going over the components here that I know have worked in the past as part of that plan and have been approved. But it really has nothing about is treatment required or not treatment required. It's more about the wells being representative. All the wells need to be the same, either untreated or treated that you're evaluating.
The next question is, what treatment process will work with PFOS?
What we're seeing that doesn't work, I'll start with that, is thermal locks. They have not been able to burn that stuff hot enough without it just reabsorbing into the air and landing on the soil at some other point. So a lot of thermal locks remediation, which works on other chemicals, does not work on PFOS. They haven't been able yet, they're studying it, to determine the temperature that these things need to be burned. So once they do that, that's probably going to become an option, even though an expensive one. What's working best now is carbon filtration. It effectively removes most of the PFOS. That's what most of the public water systems are currently using, and it's working very well.
All right,
now,
and then we have
one thing to note on that. You have to kind of keep in mind there are thousands of these chemicals, that are part of the PFAS compounds, and we're only really looking at about 16 that we sampled for today. So the remediation that we're primarily using now is for PFOS and PFOA, which are the two compounds of the PFAS entire group. A lot of those we don't have enough information yet to know what effective remediation should be used, but we do know on the two, PFOA and PFAS, that the carbon filtration works really well. That's what most of the PWS systems that have this issue are using.
Yeah, one more question. Isn't RO and GAC a proven way to remove PFAS or PFOA? And thank you for your presentation. It's just a comment.
Yep, that is effective as well. I'm not sure of what those costs are. I'm assuming that those remedial techniques may be better on some compounds than others. Just what I've seen on my experience so far, and we're kind of early into this whole remedial process of these compounds, is that carbon filtration is being used the most. So I would assume, I don't have direct knowledge of this, but I would assume that since that is being used, it probably is the most effective and effective removal, and probably cost less than some of the other techniques. I don't know that for sure, but that would be my guess.
And then one more question. You may have already answered this, but what size systems are required to submit the GWRMP, and is it based on population?
It should be submitted. First of all, no one is required to do it. Any water system can choose to sample all the wells and not submit a groundwater representative monitoring plan. Groundwater representative monitoring plans are submitted to reduce the cost of larger systems, such as the City of Tucson, which is one of the largest PWS systems in the nation that uses groundwater as their source. They have tons of groundwater wells. So by submitting and approving their groundwater representative monitoring plan, it becomes cheaper. They don't have to actually go to each well and sample where they can just use one well and sample for a cluster of wells. It's typically, but like I say, it's not required. They did not have to do that. They could sample all the wells and not submit anything. It typically will not be applicable to systems that serve under 10,000 people because those costs are picked up by EPA. So this is strictly for very large systems.
All right, thanks so much, Victor. Those were all your questions for today.